Okay, so we have calcium chloride plus sodium carbonate, and it's a double replacement reaction, and write a total and net ionic equation. Alright, so first of all we need to find out what's the other side of this equation, what it's going to make or what it's going to equal. To do that, we simply, because we know it's a double replacement reaction, so let's put this in word form first. So it's going to be CaCl2. It's also going to be plus Na2CO3. Now we need to figure out what it's going to equal. Now we know that a double replacement reaction, it's always the outsides plus the inside. So it's going to be the calcium carbonate. So it's going to be CaCO3. They both have a positive true charge, so it's fine. And then it's going to be ClNa plus Cl. In fact, I'll write this on another line, a little bit smaller. Okay, so now we need to balance this equation. Alright, so we know that we have 2 chlorides and 2 sodiums. Now, so we can just put a 2 in front of here. That's going to give us both of that, and then we're good. That's it, balanced. Okay, so now we need to write a net total ionic equation. To do this, we need to know the states of each parts of this equation. So the CaCl2, which is the calcium chloride, is going to be, if you look at your solubility rules, you know that if it says all salts containing group 7 ions, chloride, bromide, or iodide, it is going to be soluble. Okay, so it's going to be AQ. That's the same as soluble, aqueous. Now it's going to be the sodium carbonate. Now we know that all sodium, anything containing sodium is going to be aqueous, so we can put AQ. And the other side is going to be calcium carbonate. Now anything containing carbonate is going to be insoluble, so that's going to be a solid. And the NaCl, anything containing Cl or Na is aqueous, so it's definitely going to be aqueous. So now we can bring it down and write it individually. And that means you write it, so you write the Ca plus 2Cl, and both of them are aqueous. You're only going to break up the aqueous solutions, okay? You're not going to break up the solid. If it was a liquid, you're not going to break that up either. Alright, so it's going to have 2Na, that's going to be AQ also, plus CO3, AQ. Now you keep that CO3 together because that's a polyatomic ion. And the CaCO3 plus the 2Na plus, bugger, that's not going to work. Hang on, I'll just write that so you can all see it on one line. And it's going to be the CaCO3 plus 2Na, that's going to be aqueous, plus 2Cl. Okay, now anything, if it was, you always keep the aqueous or whatever state it was up here. You don't change it. So if the Ca has the AQ, so does the Cl2. If this was a solid, for instance, the Ca down here would have the solid and the chloride would have the solid. But as itself, obviously the chlorine wouldn't be a solid, but if it was in that compound, it would be. So we always keep the same state. Now we look for our spectator ions. Our spectator ions are the ones that don't participate in the equation. So we know that anything that is the same on both sides is going to be a spectator ion. So we'll look for things that have the same. So we have 2Cl on this side and 2Cl on that side. So we can cross those both off. We have 2Na on this side and 2Na on that side. But our Ca and our CO3 is changed on this side because it's all one solid. See, right here it's all one solid. Whereas these are aqueous, this is solid. So now our total ionic equation is going to be Ca, and that has a positive 2 charge. Some teachers like, put the charges. And then plus CO3, that's got a negative 2 charge. And these are both aqueous, by the way. Is going to equal CaCO3. That there is going to be our total net ionic equation.